So the first question that we are going to discuss today is dealing with n-sync versus omega sync. Now this is something that we actually derived from scratch in the class. I'm going to revisit this. The question comes from a very good student who is clearly putting in the time and effort. And the student is asking, I have a quick question regarding n-sync and omega sync on the attached question. And he actually took a screenshot of problem number 1 from the on-demand course. And he's saying that while I understand your derivation in red, converting RPM to radians per second, I don't understand how both n-sync and omega sync are the same. 120 F divided by P RPM implying n-sync is equal to omega sync. He's getting a little bit confused over here, and I'm going to address this. I think the derivation was pretty detailed in the course, but I'll take another stab at it for everyone else's benefit as well. While the formula for n-sync is in the handbook, so the student is correct, I'm not quite sure I understand how omega sync is also the same in RPM. First of all, omega sync is not in RPM. Omega sync is radians per second. Is it assumed knowledge or something I'm missing? Obviously, if they were the same, we would not call them with separate variables, so for separate names. All right. Now the issue over here is that there are multiple formulas in the reference handbook that actually use omega sync. I believe at least one in induction and at least one in synchronous. So some students, what they do is that they say that omega is equal to 2 pi f, and that's it, which is wrong. What is this? Omega equal to 2 pi f, guys. This is called electrical radiance. This is definitely not what omega sync is. So we need to figure out what omega sync is, and that's what I basically did in the derivation, right? I'll quickly go through this and I'll tell you what my response was to the student. So we start from here. One complete revolution in a closed circuit. Closed circle, this is nothing but not resembling a circle, but consider it as a circle. One revolution is equal to 2 pi radians, right? Or that is also equal to 360 degrees if you want to talk in terms of degrees. Everyone is fine with this? One rev, 2 pi radians, correct? So what we have is RPM, revolutions per minute, right? So revs per minute. So 1 rev per minute would be equal to 2 pi radians per second, correct? So 1 minute is basically equal to 60 seconds, right? So if I am going about radians per second, I'm just going to rearrange this equation, and that gives me 60 divided by 2 pi m. Does it make sense? And that's where this number 9549, which actually shows up in one of the formulas in the reference handbook, that's where this is coming from. So indirectly, they have made that connection, even in the reference handbook, but you need to know this a little bit deeply in order to appreciate it. 1 RPM is equal to 2 pi divided by 60 radians per second. Now, the disconnect over here, what the student is saying is that omega sync formula is not in the reference handbook. Agreed. How is the formula in both n sync and omega sync the same in RPM? Well, they're not. Because when you go through this derivation, all I'm saying is that you have omega sync is equal to 120 times f divided by p RPM multiplied by this. So where is this coming from? Can you guys help me understand this? How do you reconcile this? So we are going to start from here. All right. So we know that my n sync is equal to 120 f divided by p, and this is RPM. And what did we just establish here, guys? M, if you want to translate that into radians per second, I'm just simply going to substitute this piece here. That basically means that if I'm going from RPM to radians per second on the left-hand side, it will become omega sync, right? But on the right-hand side, I have to replace m with what? 2 pi divided by 60, 2 pi divided by 60 radians per second. Does it make sense? That's how you arrive at omega sync. That's how you derive this. It's not rocket science, but it does require attention to detail and connecting the dots, which ultimately is it's a fair game on the P power exam, in my opinion. So think of 2 pi by 60 simply as a constant to transform RPM into radians per second, as Chris is saying. That's one way to do it. But I don't recommend my students to try and memorize anything, because if you can make this connection that 1 rev is simply equal to 2 pi radians, you're off to the races. Correct? See how we systematically build this? Does it make sense, guys? So this is how we approached it in the course. And I think it's pretty obvious that I'm not equating n sync to omega sync. And it's actually a key distinction you have to make, right? Because omega sync and n sync, while they're talking about similar quantities, the UOM are actually quite different, right? So my response to the student was this: the equation isn't explicitly provided in the reference handbook, but if you understand the conversion between RPM and radians per second as explained in the session, is straightforward. Both represent the same physical phenomenon, but in different units. The difference between REM treated as it actually is a linear measure, correct? And radians per second is angular measure. So we start out with n sync, synchronous speed, 120 f divided by pm, as I just explained to you guys. We rearrange that equation and do the substitution and everything. We convert the RPM, switch the RPM into radians per second using 120 f by p, and we end up with this. Okay, is that clear? When using a radians per second, our calculator must be in radians. That's true. So and that applies, practically to any calculation that you're doing using radians. Make sure that your calculator is set properly. If you're doing things in degrees, it's more applicable to FE electrical, because over there we have to do integration. We have to deal with conic sections, if you guys remember, ellipse, hyperbola, angles, measurement of areas and whatnot, right? So there are multiple angles that get we get used, right? So we have to be more careful. But yeah, whenever you're dealing with radians, just be very careful how you're handling that. Okay, does it make sense? As an example, even the values are going to be different. So if I start out with a very simple, straightforward problem, let's call this a problem where the frequency is given to you as 60 hertz, and you have an induction machine that has 4 poles, right? The n sync value for that is going to be 1800 RPM, correct? But if I just use the scenario and calculate omega sync, it is something completely different, right? 188.5 radians per second. So if you carefully convert radians into revolutions, right, and into minutes, then you're going to arrive at 1800 RPM. It's a simple UOM conversion problem, right? But it's tricky because the formula is not explicitly directly provided to you in the reference handbook. And I don't think it is unreasonable for them to sort of make a problem slightly more difficult by testing you specifically on this. Make sense, guys? All right. And I received multiple questions from even students who are just using my study guides, students who are just enrolled in my on-demand program, and also from students who are enrolled in my on-demand plus live training. So I thought it's a good idea to clarify this during the office hours as well. Okay. Now, building on the previous explanation, if you see over here, what did we end up with? 4 pi f divided by p radians per second, right? 4 pi f divided by p radians per second. Another follow-up question, not a separate question that I received from student, is that I'm not following this equation. Can you elaborate how you got p divided by 4 pi f? Okay. Now this is dealing again with induction machine with a slightly different angle. Over here, we are calculating the torque, induced torque. Okay. And the student is like, I can see some equations that are given in the reference handbook, and these are the equations that are given in the reference handbook, but can you please explain how you made this substitution? Because I don't see anything that remotely relates to this. Essentially, I'm sort of reading between the lines, right? So the student was thrown off balance a little bit when I ended up using this directly, right? What he is seeing in the reference handbook is this. So how can we make the connection? Now, guys, it's okay for you to ask me these questions when you're in exam preparation mode, but 99% of the time, I've actually explained them in depth, derived pretty much everything with every single step. So you need to sort of connect the dots, and it's okay to ask questions. But on the exam, be ready that maybe they're not going to test you on something that I have already explained over here, but you may be required to step out of your comfort zone a little bit, think outside the box a little bit, right? And then connect the dots. If you don't use that muscle during exam preparation, especially with stuff that has already been explained, then you will most likely struggle. So it's part of the learning process. Consider it as part of your training, that whenever you're thrown on balance off balance and you're figuring out, okay, what do I do next? Right? It's not given in the reference handbook. Don't just throw your hands up in the air. I'm gonna come and rescue you right now, but I won't be there during the exam. Okay. So unless you start relying on yourself, your ability to actually connect the dots, it is going to be difficult for you. So consider it as part of your training, as part of your exam preparation. Now, the response that you're going to see that I provided to the student is fairly simple. As always, I'm going to explain it using first principles. So let's get to it. This is the equation, right? PAG divided by omega sync, correct? Agreed? Directly from the reference handbook, right? Now, the missing piece or the problem piece puzzle is omega sync. And the reason the student is thrown off balance is because the student was not able to find a direct formula that he could plug and play with omega sync, right? So let us zero in on omega sync. Omega sync and n sync, we've already made that connection, right? Just a couple of minutes ago. So we are all sold on the idea that omega sync is equal to 2 pi 120f divided by p, right? So this is where this is coming from. Simple, straightforward, guys, correct? Just substitute it. When you make that substitution, your T induced is going to be this, which I ended up using directly. So whenever, I'm using these formulas, I don't feel compelled to derive everything every time. If something has been explained once in depth, right? Like this derivation over here that you see earlier that we were going through, right? These are in the red and, in the black and all of this. This was my stepwise approach towards explaining, right? Now, this does not mean that you should memorize them, but there's a fine balance, right? Where you are comfortable enough attacking these problems, these concepts, these questions from first principles, and then dealing with them accordingly. Yes, I hope you found this review helpful. If you're planning to take FE Electrical and Computer exam and want to streamline your exam preparation efforts, I would recommend you to check out my website, studyforfe.com, for a comprehensive step-by-step exam preparation program. Thanks for your time and good luck with your exam preparation.